Alright, good morning 5C. Uh, this is the second video for today. You should have watched the video on me going through your electrical system SIN page 5 and 6 before coming to this video. Okay, so you should have watched the previous video on going through answers for page 5 and 6, which was your homework yesterday, and then this video will be after that. Alright, so this video will be going through your review paper that we didn't have a chance to go through in class. So we're not going to go through the whole paper, we are just going to go through the first 5 MCQ, and then we'll just we won't finish all in a few days. We will just break it up to bits and pieces so that you will learn about electrical systems, as well as you can go through your SIN, as well as you can go through your review paper um, each and every day. Okay, so we will take probably alternate days to go through the review paper, and then along the way we will also learn about electrical systems. All right, so let's get things started. Let's look at question 1. This review paper is inside your file. Remember, we put it inside your file the days before HPL started. So if you can't find this, where's this? This is actually inside your green file. Okay, it's probably in the pocket of your green file. Okay, the review paper I just gave out, I think this Monday. Okay, so dig this paper out from your green file. Should be in the pocket. Dig it out, and then make sure as I go through, you don't just look at the video. Make sure you do the corrections as well. So do the corrections as I go through the questions with you. Okay, so let's start question 1. In the diagram below, the arrow show the flow of substances A and B in a plant. So I have something that goes from the leaves to the stem to the roots. I have something that goes from the roots to the stem to the leaves. Okay, this A and B. So let's look at for a plant, let's look at the roots first. Let's start from the roots. Okay, let's start from the roots. I'll use brown color. Let's start from roots. Roots give something to the stem, and then the stem passes it to the leaves. In other words, roots transport something to the stem. Stem is transporting to the roots, but it starts from the roots. Think about it. What is the function of roots? The function of roots is to absorb water and mineral salts. I'm going to just write water over here. So roots function is to absorb water, and when roots absorb water, it transports it to the stem using the water carrying tube, and the stem transports it to the leaves using the water carrying tube. So this A over here is actually water, okay, because you realize it starts from the roots. It originates from the roots, and the roots functions to absorb water. So the roots transport water to the stem through water carrying tubes. The stem transport water to the leaf through the water carrying tubes. So substance A, not tube A, substance A is actually water. So let's write it down. Let's put a tick on water. So realize for foundation science, the options are quite far apart. It's not that difficult at all. So if A is water, of course answer is 3, but let's look at B also. So now let's look at B. We realize the arrow of B starts out from the leaves. And once again, what is the function of leaves? Think about it. The function of, okay, think about it. What is the function of leaves? The function of leaves is to make food. I think this one we are very clear on this. Roots is to absorb water, leaves is to make food, right? So the leaves make food, and after that it transports to the stem through the food carrying tube, and the stem transports it to the roots, which needs the food because it cannot make food using the food carrying tube. So this B here and this B here is actually your food. That's your food. Okay, let me write water down there also. Water down over here, right? So you realize this arrow starts from the leaves. Leaves is to make food, so leaf transport the food to the stem using the food carrying tube. The stem transports to the roots, which cannot make food, using food carrying tube also. So A is actually food. So let's see if B is really A. B is really food. Yes, B is food. So the answer is actually 3. Okay, quite simple. Alright, so you really have to think about this diagram. It's a simple diagram. You need to think about what I've learned in school, in class. Roots to absorb water, water transport to the stem using water carrying tube, transport to the leaves using water carrying tube, and then the function of the leaves is to make food, and the food is transported to the stem using food carrying tube. Same thing, transport to the roots using food carrying tube. And that's why A is water, B is food, and that's why the answer is 3. Alright, so next one, let's go. Okay, this is a plant. Okay, you realize this is the arrow. Let's highlight the arrow. This is the arrow, this is the arrow, and it's going downwards. So the general direction is that it is going downwards. So let me just draw like an arrowhead. Okay, it's going downwards. So think about it, when we did the plant model, the water and food carrying tubes, what is being transported downwards from the leaves to the roots? Right, so you realize the arrow again, they start from the leaves, and again, what's the function of the leaves? The leaves is to make food for the plant. Alright, so you realize that since the arrows start from the leaves, the material, the substance must come from the leaves, and since the leaves make food, food is being transported down the plant to other parts of the plant through the food carrying tube and down to the roots. So the arrows show the movement of what substance? Okay, and it has to originate from the leaves. So is it about transporting carbon dioxide? Do plants transport air? There's only water and food carrying tube. So this is actually wrong. Okay, in plants they don't transport air. The air just enter through the stomata, the tiny openings. Is it about transporting water? Okay, does the arrow show that the water is being transported? Let's look back at the arrows. You realize the arrows start from the leaves, and the leaves is to make food. So in this question, we are not talking about water. We are actually talking about food. So the answer is actually 3. Right? So because the arrows started out from the leaves, and the function of the leaves is to make food, so as the leaves make food, it is transported down the plant to the roots using the food carrying tube. So it is food. Alright. Okay, now let's go on to question 3. Right? Which one is false? Okay, false means wrong. So I'm gonna put a cross because false means is wrong. Okay, I want to look for statements that are wrong. Okay, let's see. Let's highlight also. Air is made up of a few type of gases. Let's think. Air is made up of a few type of gases, correct? Because I know air is made up of nitrogen, which is the biggest component, the biggest proportion of it. Made up of oxygen. It's made up of carbon dioxide. So as you think about it, you're actually revising also. And water vapor and other gases. Okay, so we know that, okay, let me make it bigger. Okay, we know that this is true because we know that air is made out of nitrogen, oxygen, carbon dioxide, water vapor, and other gases. So this is actually correct. Remember, I want the wrong one. I want the wrong one, which is here that I'm going to highlight for you. Okay, I want the wrong one, which is this. Okay, I want the wrong one. So A is correct, so I don't want A. So we go to the next one. Air is made mostly of oxygen. Air is mostly made of oxygen. We know that's wrong. This is actually supposed to be nitrogen. Because we know nitrogen has more than 3/4 of is made of more than 3/4. Air is made of more than 3/4 nitrogen. Alright. So oxygen is air is not made up of oxygen, or not mostly made of oxygen. There's only like less than 1/4 that is oxygen. So this is wrong. The correct answer should be nitrogen. Okay, so this is wrong, and this is what we want because we want those that are wrong. Air contains water vapor, correct, because we mentioned already just now. Air has water vapor, it is here also. It is here. Okay, so this is correct, which I don't want. I want wrong. So air contains water vapor, correct. So this is correct, but I want those that are wrong because I want those false. Air is in liquid state. Is it true? Before we learn about solid, liquid, and gas, is air in liquid state? No, air is not in liquid state because air no definite shape, also no definite volume. Liquid has no definite shape but has definite volume. So air is actually in gas state. It is a gas. Alright, it's not liquid state, it's actually a gas state. So this is wrong, and I want things that are wrong. So out of A, B, C, D, only B and D is wrong. B and D is wrong. Answer is 2. So I'm going to write it over here. Answer is 2. Alright, okay. So air is made of few gases is a correct statement, but I want a wrong one, so cannot be A. Air is made of mostly oxygen, which is false. It is supposed to be nitrogen, so B is correct, as in B is the one I want. Air is made of water vapor, is true, so it's not what I want. Air is actually a gas state, so this is wrong, so I want B and D. Answer is 2. Alright, 2 more questions. Okay, this mouse is a living thing. Okay, let's link it out. Let's write there living thing. Living thing. Okay, mouse is a living thing. Okay, it is in an airtight container. That means, what does it mean by airtight container? Airtight container means no air can enter or leave. Okay, sometimes it's like the Tupperware that you have or the lunchbox that you have. It is airtight. That means the air inside cannot enter, the air inside also cannot leave the container. So if you put a mouse in an airtight container, what happened to the mouse? We know that the mouse is a living thing. If the mouse is a living thing, means what does it need to survive? It needs air, food, and water. So in this case, we are more concerned about air. But I'm going to write everything down. Okay. Alright. Okay. So I know this is a mouse. A mouse is a living thing, and a living thing needs air. But now it is in an airtight container where the air cannot enter. So what happened to the mouse? It will probably die after a while. But I'm not asking whether the mouse will die or not. I'm asking you the amount of oxygen. And we know oxygen is the air we use to breathe in. So this is the air we breathe in. We breathe in oxygen. Animals also breathe in oxygen. Even plants also take in oxygen for respiration, although they also take in carbon dioxide for photosynthesis. So oxygen is the air we breathe in. This is an airtight container, means no oxygen can come in, no oxygen can go out. So as the mouse breathes in the oxygen, what happens to the amount of oxygen? Will it increase, decrease, or remain the same? I'm using oxygen now. So if I'm use the oxygen inside the container, the oxygen in the end must decrease. Alright? Okay, must decrease. So the answer is actually 2. Right? So just imagine you are trapped in a room, no doors, no windows. So you are still breathing. So you are breathing in oxygen. So if you breathe in oxygen, the amount of oxygen left in the container must decrease because you are using it up. So if you are breathing in, means you are using oxygen. And if you are using oxygen, means the amount of oxygen left in the container will decrease. Alright, so that is answer number 2. Okay, now we move on. Question number 5, the last question. Okay, the table below shows 3 organs A, B, C in the human respiratory system. Highlight respiratory system. And think about it. What are the 3 organs in the human respiratory system? We have the nose. Let's start from the top. We have the windpipe, we also have the lungs, and inside lungs we have our air sacs that allows the gaseous exchange to take place. Okay, so in our human respiratory system there are three organs: nose, windpipe, lungs. So which one is which one? Let's see. This one says A allows air to enter and leave the body. Allowing air to enter and leave the body must be the nose. Okay, the next one, it allows exchange of gases. This is basically your gaseous exchange. Okay, this is basically your gaseous exchange. Alright, so gaseous exchange don't take place in the nose, don't take place in the windpipe, it takes place in the lungs. So B is your lungs. And C, let's look at C, it transfers air that is breathed into the lungs, okay, from the nose probably. So what happens here? That it is the pipe that connects the nose to the lungs. It is called the windpipe. Alright, okay. So from the function here, I know which part it is. A is the nose because it allows air to enter and leave. B is the lungs because it allows gaseous exchange to take place. C is the windpipe because it transfers air from the nose to the lungs and from the lungs to the nose when you breathe out. So with this, it's very simple. A must be nose, B must be lungs, C must be windpipe. So the answer is 3. Alright, so I'm done with going through the answers. Make sure you have done all the corrections. You can actually pause the video, rewind, and then see the answers if I'm going too fast for you. Okay, and listen again and see if you can understand what I'm saying. So I will go through the other questions next time along during the HBL. We'll find dates that we have done too much electricity, and then we'll take a break to go through the review paper. Okay, so today there's no homework. The only homework is for you to complete your corrections. So once you're done with corrections for the SIN and for the review paper, we can take a break, and I'll see you back on Monday. Thank you.